Hello everyone, welcome to SPEC eLearn, the online learning channel dedicated to chemical engineers. Interview questions in chemical engineering. In this Q&A series, you have learned the possible questions with answers in distillation in the last 3 videos. There are more videos to be published in distillation in the coming weeks, but only after a break. Starting this week, we will move to another important subject for the interview, heat transfer, part 1. I would appreciate if you subscribe before you forget. It is a motivation to us to keep delivering free knowledge content for you to shape your career. For every question, you are given 20 seconds to think about the answer. Then the answer will appear. Check your answer is correct. Wherever required, detailed explanation is given. Now we will move on to the interview questions in heat transfer. A good understanding of concept of heat transfer and the knowledge of various type of heat exchangers is essential to function effectively in responsibilities in chemical industry. The extent of knowledge required varies from responsibilities you handle. For a production engineer, basic knowledge is sufficient. But a process engineering function, knowledge of design is also a requirement. With this understanding, we will move to the question and answers. Question number 1. A process needs a heat exchanger for a service with a cold stream at 30 degrees centigrade and a hot stream at 150 degrees centigrade, where the cold and hot stream exiting the heat exchanger are within 3 degrees approach. That is, the difference between the stream temperatures at the outlet. Which type of heat exchangers you will recommend? Explain the reason for your answer. Your time starts now. Your time is up. The answer. Plate heat exchangers is the answer. Plate heat exchangers are truly countercurrent. The temperature approach in a plate heat exchanger may be as low as 1 degree centigrade, whereas a shell and heat exchangers require an approach of 5 to 8 degrees centigrade or more. This figure illustrates the temperature profile in a countercurrent heat exchanger. The temperature difference between the hot and cold streams, called the approach, is close to 1 degree centigrade in respect of plate heat exchangers. The counterflow heat exchanger provides the most thermally effective arrangement for recovery of heat or cold from process streams. The counterflow arrangement is thermodynamically superior to any other flow arrangement. It is the most efficient flow arrangement, producing the highest temperature change in each fluid compared to any other two fluid arrangement for a given overall thermal conductance, fluid flow rates, and fluid inlet temperatures. Plate heat exchangers are 3 times more efficient than shell and tube heat exchangers. They can be easily dismantled and cleaned, hence suitable for fouling liquids also. This figure is an illustration of a plate heat exchanger with counterflow arrangement. Plate heat exchanger consists of several corrugated plates arranged in parallel and held in position between the two frames and tightened by long bolts in the four corners. Hot and cold fluid flow through the alternate plates in countercurrent direction as illustrated in this figure. Another type of heat exchanger capable of delivering similar performance is plate and fin heat exchangers. PFHEs are available in countercurrent and crossflow arrangements. Countercurrent PFHE can deliver temperature approach as low as 1 degree centigrade. However, PFHE is suitable for clean gas-to-gas and gas-liquid service at low temperatures, not suitable for fouling services. Shown in this figure is a plate fin heat exchanger which also can be used for close temperature approaches. However, its applications are limited to liquid gas applications where the fluids are relatively clean and non-corrosive. Question number 2. A petrochemical plant needs a shell and tube heat exchanger for high temperature heat recovery system. The cold and hot streams are process streams which have fouling characteristics. Which type of exchanger is suitable for the service? Your time starts now. The time is up. The answer. The suitable heat exchanger for this service is floating head heat exchanger. The selected heat exchanger should meet two performance objectives. 1. High temperature performance. 2. It should permit cleaning on both shell side and tube side due to the fouling nature of the fluids. Floating heat exchanger is a shell and tube heat exchanger with a tube bundle having a floating tube sheet that allows for differential thermal expansion between the shell and the tube bundle. The floating head heat exchanger is used in situations where 1. There is a large temperature difference between the shell and the tube bundle. 2. Applications requires tube bundle removal for inspection and cleaning. TMR type AEP/BEP or AET/BET can be used for the service depending on the service criticality. Floating heads are important types of heat exchangers in refineries and petrochemical plants for fouling services. When fouling is possible on both tube side and shell side, floating heads are generally preferred. Here you can see two types of heat exchangers shown. shown at the top is AET type heat exchanger. Front head is removable. The rear head is a pull-through floating head. In the bottom, you can see the BEP type. Here the front head is integral type and the rear head is a floating head. Both exchangers are very widely used in the petrochemical industries for severe fouling services. Floating tube sheet allows for differential thermal expansion between the shell and the tube bundle. Shell circuit can be inspected and steam cleaned. If the tube bundle has a square tube pitch, tubes can be mechanically cleaned by passing a brush between the rows of tubes. What is thermal expansion? How does it affect the tubes in the heat exchanger? All pipes and tubes expand in direct proportion to temperature change. This can be due to temperature of the flowing fluid or from the surrounding ambient temperature. This chart shows the thermal expansion of commonly used metals for manufacture of heat exchangers. Carbon steel and stainless steel are very widely used for fabrication of the tubes and shell. When the temperature is increased from 100 to 200 degrees centigrade, the thermal expansion almost doubles. This indicates thermal expansion in high temperature application, particularly in refineries and petrochemical plants, will be very high and cannot be ignored. If the tube side fluid temperature is much higher than the shell side fluid temperature, even if the material of the tube and the shell is the same, there will be differential expansion. The tubes will expand more than the shell. If a fixed tube heat exchanger is used, the tubes cannot expand freely and tube will bend as a result and may fail eventually in the worst case. For high temperature services, floating head heat exchanger is needed. Question number 3. What is the steam economy of a multiple effect evaporator? If a given evaporator has 3 effects, what will be approximate figure of steam economy and what will be relative pressure levels in each of the effect? Your time starts now. Your time is up. The answer. Steam economy is the kilogram of water vaporized from all the effects for each kilogram of steam used in or fed to the first effect. The economy of a single effect evaporator is less than 1 and is about 0.8. For n effect evaporators, the economy is about 0.8 times n. So for a triple effect evaporator, the economy is about 2.4 kg of water evaporated per kg of steam fed to the first effect. Illustrated in this figure is a triple effect evaporator. Steam pressure has to be higher than the pressure in first effect to provide heat transfer driving force for the first effect. Follow the vapor path shown by the moving red arrow. The pressure in the first effect P1 is greater than the pressure in the second effect P2, which is greater than the pressure in the third effect. As explained in the previous figure, the vapor from previous effect is used to drive the next effect evaporator. Hence, to provide heat transfer driving force, the pressure of each effect will be in the decreasing order. Multiple effect evaporators are used in the caustic soda plants for production of 50% caustic product. In petrochemical plants like Reliance Industries Limited, it is used for production of monoethylene glycol, which is used in polyester manufacture. Question number 4. Name a non-contact instrument used for measuring surface temperature of an object in a furnace. Explain which property of the object or material is used as a variable by the thermometer for the output. Your time starts now. Your time is up. The answer: pyrometer. Pyrometer is an infrared remote sensing non-contact thermometer. It is used for measuring relatively high temperatures normally encountered in furnaces. There are other online temperature measurement techniques available in the plant for continuous monitoring. Many times, hot spots can develop on the metal surfaces inside the furnace at places where the online temperature measurement is not available. For monitoring such areas, pyrometer can be used. The optical system of the pyrometer focuses the energy or the radiation emitted by the high temperature surfaces on the detector. The detector is sensitive to the radiation. Most energy of this type is in the infrared region of electromagnetic spectrum. The output of the detector is proportional to the radiation energy emitted by the hot surface less the amount absorbed by the optical system. Since the radiation energy is a function of the surface temperature of the tube, the pyrometer detector output is indicated as surface temperature. It is emissivity of the tube that is used by the pyrometer for measuring the temperature. Emissivity is simply the factor by which we multiply the blackbody heat transfer to take into account that the blackbody is the ideal case. Thus, the pyrometer output is expressed as proportional to emissivity times temperature. Emissivity is a dimensionless number which is 1 for a black body. Question number 5. Shown below is a shell and tube heat exchanger used for cooling hot gas with cooling water. Mark the fluid inlet and outlet for the shell side and tube side for the heat exchanger. Your time starts now. Your time is up. The answer. First, the fluid selection. Cooling water being fouling in nature should go to the tube side. That means the gas should be allocated to the shell side. Next is the inlet and outlet nozzle selection. Water or liquid on the tube side should always enter at the bottom. This is needed so as to ensure that water flow through all the tubes at any flow rate. On the contrary, if water enters the top nozzle, it may bypass some of the tubes, particularly at the top end of the bundle at lower flow rates. This figure illustrates the flow direction and fluid allocation for the tube and the shell side of the heat exchanger. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching.